Hi, my name is Oktay. Welcome to today's video about the chemical element bismuth. This is a nice picture of the element bismuth. It has atomic number 83. The bismuth is a brittle metal. The discoverer is unknown. Its name comes from the German word Bismuth, which means white mass. And the origin of this word could be from Arabic language. There are no stable isotopes of bismuth. However, the bismuth in nature contains the isotope 209. This is another example of the isotope with the even number of neutrons being the more stable. And there are traces of the other isotope bismuth 210. Bismuth was discovered as an element by Claude François Geoffroy in 1753. And it has a quite low melting point of just 271 degrees Celsius. This is another picture of bismuth and its multicolor surface. For comparison, at the right, that's a bismuth crystal, a cube. And this phenomenon is called iridescence. It is caused by a thin layer of bismuth oxide, and the color of this layer depends on the thickness of the oxide layer. That's why you get this multicolor surface. There's another example for iridescence. That's a soap bubble. Iridescence is a thin film interference effect. This is a picture of liquid bismuth. Bismuth has a density of 9.78 grams per cubic centimeter. That's 86% the density of lead. And like water, bismuth has a density anomaly. Liquid bismuth has a higher density than solid bismuth. So if you cool down liquid bismuth, the crystals solid bismuth will swim on top of the liquid. This is a picture of the nucleosynthesis of the origin of the chemical elements, and bismuth is in the nitrogen group here. And this purple color indicates its origin. It's from merging neutron stars. Bismuth has one advantage over its neighbor in the periodic table, that's lead here. The advantage is it is not toxic. Bismuth is not essential for life. However, you can do several useful things with bismuth. And the primordial isotope 209 comes from the S process, which is a slow neutron capture process. This is the decay chain of the isotope neptunium 237. Bismuth 209 is a part of this decay chain. It's here. And in 2003, it was discovered to be very weakly radioactive. Its half-life is 2 times 10 to the 19 years. For comparison, universe's age is 13.8 billion years, so in the order of 10 to the 10 years. This means the half-life of bismuth 209 is 1 billion times bigger than the age of the universe. If you have 100 gram bismuth, you will get 1.2 decays per hour. That's how low the radioactivity is. And the product of the alpha decay of bismuth 209 is thallium 205. This is a picture of the abundance of the chemical elements in Earth's crust. Bismuth is here. Again, much less abundant than lead. This y-axis is logarithmic. The reason is lead has an even atomic number. The elements with even atomic number are more abundant in general because they are made of the second most abundant element in nature. That's helium with the atomic number 2. You can see bismuth has about the same abundance as iodine, cadmium, silver. The concentration in Earth's crust is 0.2 parts per million. Bismuth exists in nature as native bismuth. And there are 231 minerals, for example, bismuth sulfide and bismuth oxide. These are 3 examples of bismuth in nature. At the left, that's native bismuth on quartz from the Harare district in Zimbabwe. In the middle, that's bismutite, which is bismuth carbonate oxide from Schneeberg in Germany. And at the right, that's bismuthinite, which is bismuth sulfide from Schlagenwald in Czech Republic. This is how you can produce bismuth. One way is reduction with iron, bismuth sulfide plus iron. You get bismuth metal and iron sulfide. Second way is roasting of bismuth sulfide. You get bismuth oxide. And then carbothermic reduction of bismuth oxide. You get bismuth plus carbon dioxide. But you need another step, that's a refining process. You can use, for example, chlorine gas, which reacts with the impurities but not with bismuth, to get pure bismuth. This is a picture of the world bismuth production. You can see in 2010 it was about 10,000 tons per year. And you can see prices recently gone up. In 2022, the world the production in China alone was already 16,000 tons. Number 2 producer Laos. Number 3 producer is South Korea. And the demand for bismuth has gone up because it is a very good replacement for the other element, lead. Lead, you have problems with its toxicity. This is one use of the element bismuth as an alloy that's called a Rose's metal. It was discovered by the German chemist Valentin Rose in the 18th century. This is a low melting alloy with a melting point of 94 to 98 degrees Celsius. It contains bismuth plus 25% lead and 25% tin. Rose's metal can be used for solder, heating baths, and malleable filling for tubes. This is another example of Wood's metal. It was created by Barnabas Wood in 1860. It is a bismuth alloy with 27% lead, 13% tin, and 10% cadmium. Melting point is about 70 degrees Celsius. It can be used for fuses, heat baths, and as a valve element in sprinklers. This is another important compound, bismuth oxide, Bi2O3, can be made by heating of a bismuth subcarbonate or bismuth hydroxide. There are several uses for this compound, for example, in a solid oxide fuel cell, or for glasses or fireworks, or as a radiative cooling paint. This is how it works. It's called passive daytime radiative cooling, PDRC. This is a non-toxic paint with a high reflectivity. 3 weeks ago, I made a video about Saturn's moon Enceladus. It has a high albedo, which means it has a high reflectivity. So that's why its surface temperature is very low. You can use this effect to paint the top of the building with this paint. The advantage is it has no energy consumption, and you only need to paint the top of the roof because you want the radiation from the sun to be reflected, not absorbed. And you want the lower sun in the winter to heat up your building. That's why you don't paint the sides of the building. That's how it works. This is another compound, bismuth oxychloride, BiOCl. You can see in the picture the layers of oxide ions in red, bismuth ions in gray, and chloride ions in green. It's a white solid with pearly iridescence. It exists in nature as the mineral bismuclide. Bismuth oxychloride can be used for cosmetic products, for example eyeshadows and nail polishes, and it was also already known and used in ancient Egypt. This is a picture of mineral pucherite, which is bismuth vanadate. It's from Hohenstein in Germany. This is the compound bismuth vanadate, BiVO4. It's also called pigment yellow 184. It's a beautiful, bright, pure color and a high tinting strength. This compound is also known for its low toxicity. That's why the demand is increasing. And there's another use for this compound, that's as a photocatalyst for splitting of water. This is a bismuth strontium calcium copper oxide, also called BiSCO, I've made another video about superconductors. You can check it out if you're interested. This was the first high temperature superconductor that contained no rare earth element, and it was the first superconductor that was used from making wires. It was discovered in 1988. This is one example of this group of compounds, Bi2S3, Ca2CO3, O10 plus X. The X is important because this is a non-stoichiometric compound. And this is a type 2 superconductor. The critical temperature is 108 Kelvin, which is above the boiling point of liquid nitrogen, which is at 77 Kelvin, or minus 196 degrees Celsius. That's why it's called high temperature superconductor. And the holy grail, of course, the research of superconductors is finding a superconductor that works at room temperature. This is bismuth subsalicylate, also called Pepto-Bismol. This is an ad from year 1957. This is a medicine, anti-inflammatory, antibacterial, and it has minor side effects. The side effects are black tongue and black stool. This compound can be used for stomach problems. At the right, you can see the structure of this compound. This is a very interesting picture from 1914. It shows a nurse feeding a baby with the milk of bismuth. Milk of bismuth is a mixture of bismuth subcarbonate, BiO2, CO3, and bismuth hydroxide, BiOH3, and water. This was used for stomach washing to prevent vomiting. And this works because the bismuth ions damage the walls of the bacteria, so they can't survive. You can also add charcoal to the milk of bismuth. Charcoal has a high surface, a big surface, and all kinds of compounds can bind to the surface of charcoal. This is called adsorption. So these compounds are filtered out of the stomach liquids. That's how it works. This is a nice picture of a synthetic bismuth crystal, and you can again see the effect of the iridescence of the bismuth oxide layer. And this is a nice picture I found when I did the research for this video. This is was called Gold People. A nice picture. And that was today's video about the chemical element bismuth. Thank you for watching. Have a nice day. Bye bye.